this part, we will discuss about some tricky problems about binomial expansion. So we have already discussed about the binomial expansion of two parts. The first part we have discussed the binomial expansion, that means in general how to find a plus b whole to the power n, and the second part we have already discussed terms, coefficients and middle terms also. Here we will discuss how to find the term independent of x. Okay, so the basic key concept of this topic we have already discussed in the previous class, and we continuing that theoretical part in this video. So we will solve some tricky type problems. The first problem is, so the main part is that in this video we have to calculate the term independent of x. Okay, so now the first problem is that find the term independent of x in the expansion 3 by 2x square minus 1 by 3x whole to the power 6. Find the term independent of x in the expansion of 3 by 2x square minus 1 by 3x whole to the power 6. So I have to determine the term which is independent of x. So which term is independent of x, I don't know. So that's why let us assume that r plus one term be independent of x. Okay, so proceed. Let us assume that r plus one term is independent of x. So let us assume that r plus one term is independent of x, and we know that we have already discussed about what is the formula of r plus one term, that is tr plus 1 equals to ncr a to the power n minus r into b to the power r when we expand a plus b whole to the power n. In the expansion of a plus b whole to the power n, the r plus 1 term is ncr a to the power n minus r into b to the power r. Here the expansion is given to you 3 by 2x square minus 1 by 3x whole to the power 6. So n equals to 6. So I have to determine the value of r. So now tr plus 1 equals to, here n equals to 6, so that's why I have written 6cr, and here a equals to 3 by 2x square, 3 by 2 into x square whole to the power n minus r, because n is 6, so that's why I have written here 6 minus r into b. B means 1 by minus 1 by 3x whole to the power r. Now I simplify it and do some calculation. 6cr 6 minus r by 2 to the power 6 minus r into x square whole to the power 6 minus r according to the law of indices, and this can be written as minus 1 by 3 whole to the power r into 1 by x to the power r. Okay, so now simplify it. 6cr 3 to the power 6 minus r by 2 to the power, of course you can write down also 3 by 2 whole to the power 6 minus r, and minus 1/3 whole to the power r and x to the power 12 minus r. After multiplying, because using the indices rule, x to the power m whole to the power n, just I use this formula, whole to the power n equals to x to the power n into n. So that's why I have written 2 into 6, that is 12 minus 2 into r, that is minus 2r, and also by x to the power r, so x to the power minus r. Okay, according to the indices rule, x to the power n by x to the power n, that gives x to the power m minus n. So now after some calculation, 6cr 3 by 2, 6 minus r and minus 1/3 whole to the power r, x to the power 12 minus 3r. So now according to our assumption, this term is independent of x. That's why this term is free from x. So how to free it? Of course, if this value is 1, then we will get only in the term contains only the constant part. There is no variable, no x present in this expression. So if I have to put this value equals to 1, because we have to find out the term independent of x, or we have to find out the term which is free from x. Free from x means, so according to our assumption, so this must be 1. So according to the indices rule, we can write down this is x to the power 0 also. So x to the power 12 minus 3r equals to x to the power 0, and we know that a to the power n equals to a to the power n according to the law of indices, n equals to n. So that's why I have to put here 12 minus 3r equals to 0, and this gives r equals to 4. So we have gotten the value of r, and now we put the value of r in this expression tr plus 1. Okay, so this is my tr plus 1. I have simplified form of tr plus 1 and put the value tr plus 1. That means r gives the value 4. So t4 plus 1. That means the fifth term is the independent of x. The fifth term. So t5 equals to, you can write down t4 plus 1 and put r equals to 4. You will get 6c4 3 by 2 whole to the power 6 minus 4 minus 1/3 whole to the power 4, and you have already taken this value is 1, and if you put r equals to 4, so 12 minus 12, that is x to the power 0, that gives 1 also. So after some calculation, we will get 6 factorial by 4 factorial into 6 minus 4 factorial according to the NCR formula, and this is 3 by 2 whole to the power 2, and minus 1/3 into minus 1/3 into 4 times 1/3. If we multiply, we will get 1 by 3 to the power 4, and 4 times of negative sign you always get positive value. So after some calculation, 6 into 5 into 4 factorial, we have done it elaborately in NCR and NPR session. Okay, so 4 factorial, and 2 means 2 into 1, so 4 factorial cancelled. This is 9 by 4, and this is 1 by 81. Okay, so now so 2 3, if I divide it, and 9 81. Okay, so I have gotten 315 at 3 to the power 4 and 3 by 2, that is 3 square by 2 square, that is 2 square means 4. So 3 and 6c4 means minus 1 to the power minus 1 by 3 whole to the power r, and I have gotten r equals to 4 and put the value 4 factorial, that is 2 factorial, and 2 3 6 and 4 factorial cancelled. You will get 15 by 36. After some calculation, if we divide 3, so we will get 5 by 12. So the fifth term is independent of x and the value of the fifth term is 5 by 12. Okay, so find the term independent of x. So the independent of x term is independent of x term is 5 by 12. Also it is a fifth number of term. Okay, so I think we have been solved clearly the problem number 1. So next we proceed the second problem. Okay, so I erase it. I think you have already written it, already copied. Okay, now we will solve the another problem. I must read the problem. Okay, so the another problem is that find the term independent of x in the expansion of cube root of x plus 1 by 2 into cube root of x whole to the power 18 where x greater than 0. Okay, we have already, this type of problem we have already solved. So let us assume that r plus 1 term is independent of x, in the expansion. So now tr plus 1 equals to, according to the formula we have already discussed in the previous problem, NCR, that is 18CR a to the power cube root of x whole to the power 18 minus r, that means n minus r, into b here 1 by 2 cube root of x whole to the power r. Now I simplify it. 18CR, you can write down cube root of x means x to the power 1/3 whole to the power 18 minus r, and 1 by 2 and x to the power 1/3 whole to the power r. And next step, 18CR x to the power 18 minus r by 3 and 1 by 2 to the power r, 1 by x to the power r by 3. So now I club all the constant parts on the left side, 18CR 1 by 2 to the power r, and according to the indices rule 18 minus r by 3 minus r by 3. Okay, so now next simplify it. 18CR 1 by 2 to the power r x to the power 18 minus 2r by 3. That gives tr plus 1. I am boxing it. Okay. So according to our assumption, this is tr plus 1 is independent of x or free from x. So that's why it must be the value of this quantity is always 1. If it is 1, so tr plus 1 is independent of x and it is a constant. So according to our assumption, x to the power 18 minus 2r by 3 equals to 1. So that's equals to x to the power 0 by indices rules. So x to the power 18 minus 2r by 3 equals to x to the power 0. That gives 18 minus 2r by 3 equals to 0. So 18 minus 2r equals to 0. So this gives r equals to 9. So after simplifying it, we have gotten the value r equals to 9. And if you know the value of r, then you will get the term. So which term is independent of x? If I put r equals to 9 in this expression, so we will get t9 plus 1. That means you can consider t10. That means 10th term. 10th term is independent of x. And the value of the term is 18c9 into 1 by 2 to the power 9. And if I put r equals to 9, so 18 minus 18, that is also 0 because I have taken this value is 1. So the expression is t9 t10 or t9 plus 1 is 18c9 into 1 by 2 to the power 9. That gives the answer. Okay, so the term independent of x is therefore the term independent of x in the expansion is 18c9 into 1 by 2 to the power 9. Problem number 3. The sum of the coefficients of the first three terms in the expansion x minus 3 by x square whole to the power m, where x not equal to 0, m being natural number, is 559. That means 559. Find the term of the expansion containing x cube. So I repeat, the question number 3 is the sum of the coefficients of the first three terms in the expansion. So if I expand this, the sum of the first three terms, coefficient of the first three terms is 559. And also the condition is given that m is natural number and the expansion is given to you x minus 3 by x square whole to the power m. So I have to determine the value of m, and the second part, find the term of the expansion containing x cube. Okay, first I have to determine the value of m, and you see that if I expand now, if we solve this problem, so how to expand this expansion? So x minus 3 by x square whole to the power m, if I expand this up to some terms, so first term is x to the power m plus mc1 x to the power m minus 1 into minus 3 by x square whole to the power 1 plus mc2 x to the power m minus 2 minus 3 by x square into whole square plus mc3 x to the power m minus 3 minus 3 by x square whole to the power 3 and so on. So in the question given that sum of the coefficient of first three terms, this is the first term, this is the second term, and this is my third term. So I have to add all the coefficients of first three terms. First I have to simplify the terms. Okay, x minus 3 by x square whole to the power m. If I write this is x to the power m, and this minus 3 into mc1 x to the power m minus 1, and if I take to the power minus 2, that is x to the power m minus 3 according to the indices rule. And this is minus 3 whole square, that is you get 9mc2 x to the power m minus 2 and x square to x to the power 4, that is you will get x to the power m minus 6 plus so on. So and this is plus, of course, because minus of minus whole square, that means plus. So the sum of the coefficients of first three terms, sum of the coefficients of first three terms is, sum of the coefficients of the first three terms is 559 equals to 1 minus 3 into mc1 plus 9 into mc2 equals to 559. So from this relation I have to determine the value of m. So 1 minus 3 into factorial m by 1 factorial into m minus 1 factorial, and if we know that the value of mc1 always m, but I have to calculate here m factorial by 2 factorial into m minus 2 factorial equals to 559. So now 1 minus 3 into m minus 1 factorial by m minus 1 factorial and plus 9 into m minus 1 into m minus 2 factorial by 2 into 1 into m minus 2 factorial equals to 559. Okay. Up to this part it is clear to you. So now I simply cancel m minus 1 factorial in this quantity, and this is the common part, I have to cancel it. So we have gotten 1 minus 3m plus 9m square minus 9m by 2 equals to 559. So after some calculation we will get 2 minus 6m plus 9m square minus 9m equals to 2 9 18 1 Okay. So from this expression we have gotten the quadratic equation of m, 9m square minus 15m minus 116 equals to 0. So if I multiply 9 into, if I factorize this expression, so 9 into 1,116, that gives 54 4 10 1004. Okay, so now I factorize it to 5022 225 11 3 10 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 11 3 2 6 3 9 3. So you see that 2 to the 4, 4 into 3 12, 12 into 3 36, 36 into 3 108. So 108 minus 93 you will get 15. So you have gotten this expression. So now if I factorize it, 9m square minus 108m plus 93m minus 116 equals to 0. If I take the common part, 9m equals to, we have got an m minus 12. Here also 93 is the common, you will get m minus 12 equals to 0. Okay. So if I write it clearly in this section, so we will get m minus 12 into 9m plus 93 equals to 0. So this gives m equals to m minus 12 equals to 0, m equals to 12. So it cannot be equals to 0 because the condition is given to you here. The condition is given to you in the question that m is being a natural number. Natural number always positive, that cannot be a fraction. So what is the value of m when the coefficients of the first three terms is 559? So the value of m is 12. Therefore, the value of m is 12. So the second part of the, find the term in the expansion containing x cube. So continuing this problem, so we have already gotten the value of m. So the now present expansion, so next part we have to determine the coefficient of x cube in the expansion x minus 3 by x square whole to the power 12, because I have already gotten the value of m. So let us assume that r plus 1 term contain x cube, r plus 1 term containing x cube. So till r plus 1 equals to NCR, that is 12CR, a to the power n minus r, that is x to the power 12 minus r, into b to the power r, that is minus 3 by x square whole to the power r. So now I simplify it, 12CR x to the power 12 minus r minus 3 to the power r by x to the power 2r. Okay, I think you have already written in this part, in this portion of the board. I erase in this portion. Okay, and write down here also. So what I have gotten? I have gotten TR plus 1 equals to 12CR. So if I write 12CR into minus 3 whole to the power r into x to the power 12 minus r to the minus 2r, that gives minus 3r. Okay, clear? So according to our assumption, this must, since this term contains x cube, so that x cube contribute only this part. Okay, so it must be x to the power 12 minus 3r must be x cube. So from this equation we will get the value of r. So according to our assumption, x to the power 12 minus 3r equals to x cube. Okay, x to the power 12 minus 3r equals to x cube. Because I have taken here, let us assume that r plus 1 term containing x cube. So according to the indices rule, 12 minus 3r equals to 3. That gives 3r equals to 9. So we have gotten r equals to 3. And now if we put the value of r in this expression tr plus 1, so tr plus 1, we get the term which contains x cube. Okay, so t3 plus 1, if I put in this expression r equals to 3, we get 12c3 minus 3 whole to the power cube and x to the power 12 minus 9. So 12 factorial by 3 factorial, 12 minus 3 factorial, and 3 cube. So that is 27 first of all, and second of all, this is the minus, I multiply minus 3 times, so we will get minus 27, that x cube. Okay, so I have to find out the only term, not coefficient. So the term is the fourth term, that means fourth term contain x cube. So after some calculation we will get 12 into 11 into 10 into 9 factorial by 3 into 2 into 1 into 9 factorial. These are cancelled. Minus 27 into x cube. So 3 to the 6, 12. So 220 into 27, and negative sign present here because 6 to the 12 and 6 to the 12, 2 into 11, 22, 22 into 10, 2 to 0 into minus 27. So that's x cube. After some calculation, if I multiply 27 and 22, 54 into 54, so we have gotten 495. So minus 5940 x cube. This is t3 plus 1 or t4. So the term, fourth term, which contains x cube, and the term is minus 5940 into x cube. Okay, so I think this question contains two parts. Okay, so we have already done the first part, the value of m. So we have calculated value m equals to 12, and another part, after putting the value of m, that means after putting the value 12, find out the term in the expansion containing x cube. Okay, I think you have already copied, so we proceed the next problem, most interesting problem. Okay, so now I erase this part. Find the n, the problem number 4, find the value of n if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion of fourth root of 2 plus 1 by fourth root of 3 whole to the power n. So I have to calculate, I have to find out the value of n. So find n if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion fourth root of 2 plus 1 by fourth root of 3 whole to the power n is root 6 is to root 1. That means I have to determine the value of n when the first fifth term, and from the end of the last fifth term their ratio is root 6 is to 1. So I have to determine from this relation the value of n. Okay, so if I write the expansion, if here a equals to fourth root of 2 plus 1 by fourth root of 3 whole to the power n. Okay, if I put in this fashion 2 to the power 1 by 4 plus, according to the indices rule, 3 to the power 1 by 4 whole to the power n. If I expand it, so the fifth term, the first term is nc0 2 to the power 1 by 4 whole to the power n, and the second term is nc1 2 to the power 1 by 4 whole to the power n minus 1 into 1 by 3 to the power 1 by 4 whole to the power 1. This is my second term. Okay, so what is my fifth term? So of course, this, if for 1 this is the second term, so the fifth term is nc4 2 to the power 1 by 4 whole to the power n minus 4 and 1 by 3 to the power 1 by 4 whole to the power 4. Okay, and what is my last term? The last term, of course, ncn 1 by 3 to the power 1 by 4 whole to the power n. If I expand in the form of a plus b whole to the power n, you see that this is the first fifth term from the beginning, and I have to find out the last fifth term, that means the fifth term from the end. So this is the end term. The previous term is ncn minus 1 2 to the power 1 by 4 1 by 3 to the power 1 by 4 whole to the power n minus 1, and this is the second from the end, and third is ncn minus 2, fourth is ncn minus 3, and fifth is ncn minus 4. So ncn minus 4 2 to the power 1 by, this is end term n minus 1 to the power 1. This is the second end term, third end term, that means n minus 2, fourth end term n minus 3, fifth, this is fifth end term ncn minus 4 2 to the power 1 by 4 whole to the power 4 1 by 3 to the power 1 by 4 n minus 4. Okay, more terms present in the middle. Okay, so the first fifth term is from the beginning of the expansion is this nc4 2 to the power 1 by 4 whole to the power n minus 4 into 1 by 3 to the power 1 by 4 whole to the power 4, and the fifth term from the end is ncn minus 4 2 to the power 1 by 4 whole to the power 4 into 1 by 3 to the power 1 by 4 whole to the power n minus 4. So according to our condition and from the given question, by the given condition, so ratio of these two terms gives root 6 is to root 1. So nc4 2 to the power 1 by 4 whole to the power n minus 4 1 by 3 to the power 1 by 4 whole to the power 4 by ncn minus 4 2 to the power 1 by 4 whole to the power 4 and 1 by 3 to the power 1 by 4 whole to the power n minus 4, that gives root 6 by 1. Now we know if you remind the result, what about the value of NCR and NCN minus R? Both the value are same. We have already discussed in the previous class, and if you write down the expression, both are same. So NC4 and NCN minus 4 both are same, so this can be cancelled. So if I simplify it, 2 to the power n minus 4 by 4, and this gives 1 by 3, 3 to the power 1 by 4 into 4, that was cancelled, we will get 3 to the power 1. So 1 by 3 to the power 1, that is 1/3, and 2 to the power 1 by 4 into 4, that gives 2. Okay, 2 to the power 1 by 4, and 1 by 3 to the power 1 by 4, that gives 1 by 3 to the power n minus 4 by 4. So that gives 3 and 2, that's equals to root 6. So from this expression, from after implies, we can write down here also 2 to the power n minus 4 by 4 minus 1 and 3 to the power n minus 4 by 4 minus 1 equals to root 6. If we assume that, so if I take 2 to the power 1, that is 2 to the power minus 1, so according to the indices rule, n minus 4 by 4 minus 1, and 1 by 3, that is that goes to numerator part, and 3 to the power n minus 4 by 4 by 3, that means 3 to the power n minus 4 minus 1. So that gives 2 to the power n minus 8 by 4 into 3 to the power n minus 8 by 4 equals to 6 to the power half also. So you can write down 2 into 3 according to the indices rule, n minus 8 by 4, that gives 6 to the power half. So now if I calculate here also, so we will get 6 to the power n minus 8 by 4 equals to 6 to the power half. So according to the indices rule, a to the power n equals to a to the power n, that gives m equals to n. So this gives n minus 8 by 4 equals to half. So after some calculation, n minus 8 equals to 2, this gives n equals to 10. So I have to determine the values of n. So the value of n is 10. So find n, the question is given to you, find n. So the value of n is, therefore the value of n is 10. Okay. So I think it is clear to you. So I have cancelled NC4 and NCN minus 4 because we know the result NCR and NCN minus R both are same. So if any confusion arises, so I have to calculate NC4 factorial n by 4 factorial into n minus 4 factorial, and NCN minus 4 according to this is a factorial n by n minus 4 factorial into n minus of n minus 4 whole factorial. So n minus n cancel, minus, that is plus 4. So factorial n by 4 factorial into n minus 4 factorial. So that's why I have cancelled there NC4 and NCN minus 4. So I have gotten the result. Okay. I think it is clear to you and you have already copied. So this problem is most important problem. So previous problem also important. Okay. So in the next class we will discuss about some tricky problems about binomial expansion. Okay. Thank you.